Hello ladies and gentlemen, I hope I'm going live about now. Please apologize the OBS view right now, but I'm really meticulously looking at the drops frames rating because that has been a big problem when I started to stream yesterday. This is the stream I wanted to do yesterday, but then alas I could not, unfortunately. My iPad did not yet start the stream. Well, it has now, and it seems to be working rather well, thank God. I was really worried that my internet problems from yesterday might be repeated today, but it seems like we're all fine. Hello, ladies and gentlemen, again. Today we have a very interesting stream. We already have some messages in the chat that I definitely would want to react to. Beyond that, I of course want to encourage you to let me know if there is something wrong with audio and video throughout the stream. I'll be happy to try to deal with those problems. Hopefully we won't get any though. We have like a windstorm going on. I've already tried both Wi-Fi and 5G, so we'll see how it goes. But regardless, I'm really excited. I know many of you are excited. I know that some of the most successful content on this channel has been like processor stuff. Like you guys are really always excited to know what is new in the world of Apple Silicon. Over the course of yesterday, we added like 18 new subs, which is fantastic. Thank you guys so much for that. My iPhone does not want to sit straight on my MacBook, so I apologize if it's like slightly skewed, the perspective on my face. But yeah, I think it's time to really dig in deep because, well, obviously we don't yet have all the information we might need, but I think we have gotten enough to start talking about it. And obviously, as M3 launches officially on November 7th and Snapdragon X Elite is still like 6 to 8 months off, I think it's very important to start with M3 because, well, that is the thing that is actually available soon. So, of course, with M3, we are getting M3, M3 Pro, and M3 Max. And exactly with M3, well, what are we getting? Well, M3 is a 3nm processor. It's supposedly, and by the way, this is sort of a leak, but not from me, guys. I've obviously engaged with a lot of Twitter threads yesterday when it comes to benchmarks and stuff like that. I was trying to get some extra data. Vadim Yuriv from MaxTech sort of confirmed or sort of implied that it's actually built on ARM v9, which, if you know the benchmarks for the A17 Pro, that one is actually built on ARM v8. So it might actually be a significant boost in the architecture. Now, when it comes to like the way Apple advertised it, right, with the better branch prediction, stuff like that, it sounded pretty much like the same course as on A17 Pro. And in fact, it just lines up with the A17 Pro. It's ever so slightly higher clocked, which is what Apple does. M2, for example, was higher clocked than A15. So I obviously cannot guarantee that it's ARM v9, but I just wanted to let you guys know. Obviously, Apple has been a little late, you could say, to adopting ARM v9. My theory to that is that the processors we are getting this year are largely the processors we were supposed to get last year, and that's because obviously 3nm was delayed and Apple couldn't fully like backport the new architecture to 4nm or 5nm. So what we are getting now is sort of the M3 that was supposed to come out last year with some new features built on top of that. But let's get into the actual hard numbers, because we're starting to get Geekbench 6 results. You can actually see them here. I've chosen the highest one because I always find that pre-release numbers tend to be a little low. That also was the case for the A17 Pro, that was more around the 2800 range, maybe 2850, and then real world tests showed it more to be like 2920 to 2940 when it comes to single core results, for example. So with our first M3 results, for one, we are seeing that those are clocked at over 4 gigahertz, the performance cores at least, right? That compares to 3.78 gigahertz on the A17 Pro, so that's actually almost 0.3 gigahertz. It's 0.27, but let's not be too pedantic, right? It's the same 8 core setups with 4 performance cores, 4 efficiency cores. Cache in Geekbench can sometimes be a little off. It seems to be like it's inheriting the cache structure of the M2 largely, but I'll wait for like more deeper breakdowns of it before I actually confirm or deny that kind of information. And of course, we are getting our 3076 scores here, single core score that, as I said before, compares to around 2940 on the A17 Pro single core results, and we're getting 11,863 points in multi-core. Guys, let me just briefly check. Okay, our dropped frames are doing more than fine, just 0.1%. Just wanted to make sure that you guys have a nice experience. Please, as always, let me know if there's anything wrong with the audio and stuff like that. I always want to maximize basically your viewing experience. Now, obviously, we have some summaries from other sites here. M2 came to 2,600 points in single core result. We can actually directly go to Geekbench here. I do like doing that, where you can see that the base M2 chip, which is clocked a little lower, where is it? Here, it's at 3.5 gigahertz. It's around 2640s where you would see most of the higher results. And then the M2 Max could clock to 3.7 gigahertz. This is why this is closer to 2800, at least on the Mac Studio. I don't know if the MacBooks have actually real problems reaching 2800. I mean, this is a very small difference between 2736 and 2800, but regardless, this is higher than all of them. And when it comes to multi-core results, this is actually really impressive. Now, all by itself, yes, that kind of uplift is expected. I mean, we are hitting a new node, but for example, the multi-core result from the M3, the base M series chip, was higher than the 28-core Mac Pro, the last Intel one we got. So this is actually pretty hilarious. The multi-core score we got was 11,700, or with the test that I showed you, closer to 11,900. If we actually see where that fares, that's super close to the actual M2 Pro, which is of course the chip that has 6 performance cores and 4 efficiency cores. That's the base version, and it's actually really close to the M1 Max, it having 8 performance cores and 2 efficiency cores. Given as I said, that pre-release benchmarks tend to be a little bit on the lower side, it might actually almost match them in once those devices are actually out. Obviously, I don't guarantee you will get 300 points more than the benchmark I just showed, but I think it's actually pretty nice. And when you compare it to like no, wait, I apologize. I've actually misspoken. I said that the M2 Pro here is the 10-core version, which means it's, I said it's 6 plus 4. No, it's 8 plus 2. Sorry, I forgot briefly how the M1 was structured. This is actually a really relevant comparison. I really apologize for misspeaking right now. This is the M1 Pro with 8 cores, which is, obviously, that's the same core count as on the M3, but this is 6 performance cores and 2 efficiency cores, and this is way below the M3 results. So again, really nice tests here. I should also notice that you can see that the 28 core Mac Pro is barely any faster than the 16 core version, so it's not like it's more like the limitation of the specific chip that Apple got. That's actually really nice. There isn't that much more to say to the base M chip, except for if you obviously compare it to like specifically to which chip, right? It's 20% faster than the M2, which is what Apple promised in terms of uplift, and the M2 was itself 17% faster than M1, so this is actually a larger generational uplift, which obviously in an era of somewhat diminishing returns for hardware is actually pretty impressive. This is just the core layout here. Apple talked a lot more about the GPU's capabilities rather than its raw performance. They're saying it's up to 65% faster than M1, up to 20% faster than M2. I do have some GPU results that I really encourage you guys to take with a grain of salt for several reasons. This is Vadim Yura from MaxTech retweeting or reposting on X, however you want to put it, some results for GFX Bench when it comes to the M3, and supposedly we're talking about 10 core version, so this is not binned in any way, and it's just 7.4% faster, which was obviously below Apple's claims. Now, for example, the A17 Pro is supposedly 20% faster than the A16 chip, but it also has 20% more cores. Now, M3 is being compared to the M2, which is closer to the A15 than it is the A16, but the A16 was barely any faster than the A15. So in this case, could it make sense? Yes. I highly encourage you guys, though, like, GFX Bench is really not a well-maintained benchmark, right? It's not upgraded with like support for the latest graphics APIs and stuff like that. Well, sometimes it is, right? But this does not obviously test ray tracing. That would be supposedly twice as fast or something like that. This does not take good advantage of dynamic caching. I know Apple said that it's like completely transparent to developers, and whatever you build, your processor takes care of it thanks to dynamic caching. However, the problem with that perspective is if your benchmark is built on a really old API at this version, well, then you will have problems with that kind of performance uplift that is baked more into architectural changes than raw compute uplift. So I want to refrain from giving too much data on GPU results and talk more about CPU today, but we will get to some GPU results as well once we hit the Snapdragon X Elite. By the way, guys, I highly encourage you guys to join the chat. I see you, Inamu, who you said that Snapdragon X Elite beats Apple M3. I will have, believe me, my 2 cents about that kind of comparison point, because I don't think it's a very valid one. I also think it's pretty funny given that Snapdragon X Elite will not launch until the middle of next year. But I do encourage you guys to chat with me live, to give me to check me basically if I'm wrong on something, to provide your own 2 cents on the story. So I really want us to have a lively conversation. This is why I run this part of my channel mostly through live streams. The other chip we've gotten results is actually the biggest M3, right? So we're moving from the smallest one to the biggest, and that's the M3. It seems like we still haven't had single core results for M3. I've seen some websites posted at around 3200. I don't know how believable that is. I think it would make perfect sense if Apple increased the clocks further to like 4.2 gigahertz. But for now, I don't want to commit to any single core results. However, it seems very likely. Now, this is the single core result that it had for this benchmark. Obviously, I wouldn't put too much into it. 2980, that's basically in the realm of A17 Pro, given that M3 Max will clock pretty high. I don't yet fully know if M3 Max actually clocks significantly higher than M3, but of course it will clock higher than A17 Pro. So as I said, pre-release benchmarks, take them with a grain of salt. Usually understand them to be lower than what actual devices will do once you set up a benchmark correctly. But I think the multi-core result here actually makes a lot of sense, given that we are dealing here with 12 performance cores and 4 efficiency cores. So we are coming out at around 20,800. Now, where does that lead us exactly? Well, if we go to the multi-core benchmarks here, well, that leads us to basically the top. I have no idea why my mouse refuses to scroll right now. So this is basically just below the M2 Ultra. I've seen some other tests where it's like 3% ahead. So I would say it's basically a match for the multi-core performance of the M2 Ultra, which, as you know, is a 2-die version of the M2 Max, basically glued together. This one has 24 CPU cores. I believe consistent of 16 performance cores and 8 efficiency cores. So the fact that it matches that with 12 performance cores and 4 efficiency cores is incredibly interesting here. Again, no benchmarks for the GPU on the M3 Max. That one is likely the chip that is going to have the largest generational uplift, because it's also pretty much the only one that got more cores, right? At least on the high end, we now have a 40-core version versus 38 before. It also has no bandwidth problems, potentially, like the M3 Pro might versus M2 Pro. M3 Max definitely the most interesting chip here, and the fact that it's getting such high multi-core results. By the way, this is the Mac Pro that we got just a few months ago, and this is a $7,000 machine, while you can configure an M3 Max 16-inch MacBook Pro for $4,000. So that's $3,000 less. Sure, it will likely underperform it in like raw GPU performance, but then it will also have like ray tracing that will push it further ahead. It also has like great memory support with up to 128 gigabytes. So yeah, the Mac Pro is like really cursed. The 2019 Mac Pro obviously being like this shit show here, and now the Apple Silicon Mac Pro, the first one. The Mac Pro really should only exist as a machine that supports extreme chips, which would be a quad die solution. And the fact that it was the same processor as on the $4,000 Mac Studio, not even the full GPU core version, that was always wrong. And I'm really glad that Apple is basically like cannibalizing this device once more, so that they know in the future, if they actually want to launch a new Mac Pro, they better make sure it's somewhat future-proof. YouTube Kulanchizi, M3 Max clock is a little lower than I expected, given that M2 Pro ended up clocked 5% higher than M2. It wasn't the M2 Pro, right? It was only the M2 Max that was clocked higher. Here, look, it's M2 Max was clocked at up to 3.7 gigahertz, and M2 Pro was clocked at the same 3.5 gigahertz as the base M2 chip here. And then when I actually, and I believe the A15 was clocked a little below that. When we look at the M1, was clocked across the board the same way. So it could be the case that we might get an M1 situation here, and M3 is clocked the same across the board. I came into this with the assumption yet, but yes, I should make sure. I don't know yet if M3 Max is actually clocked higher than M3 in this way. It's not necessarily that it will happen every generation. Just because they were able to do that at 3.7 gigahertz doesn't mean they'll be able to do it. But exactly. I think they would still be able to, but the question is like, what would be the point if, for example, a generation might not really scale that well past the peak frequency we are talking about, right? If beyond 4 gigahertz to go to 4.2, you would be getting less than 5% more performance potentially, but paying for that with 20% more or 30% more power consumption, then Apple will not do that. M2 scaled pretty well to 3.7. I obviously cannot guarantee how M3 scales. Sometimes new nodes are actually not that great in giving us super high clock speeds. For example, like when Intel switched to like finally from 14 nanometer, it took them a while until they got their new node to clock just as high as their previous one, and then over time they got that to clock even higher. But yeah, YouTube Kulanchiza, you are 100% correct. I do not guarantee that M3 Max is clocked higher, but I also would take pre-release benchmarks in general with a grain of salt when it comes to single core results. I also don't know how exactly Apple's high power mode will behave. Yeah, I'll just leave it to that. Obviously, as I said, thank you for, I wouldn't say it's correcting me. I would say it's providing more nuance and detail. I always encourage you guys to do that. But yeah, I shouldn't have spoken basically more surely than I am. Now, beyond that though, this is what we gotten. Obviously, this is highly impressive. This one is in line with what Apple promised. The GPU results might not be exactly depending on the benchmark. I do find that both GFX Bench and 3D Mark these days are just not well maintained enough, especially not GFX Bench, to actually keep up with newer architectures. They're really good at testing like old results basically, but when it comes to taking advantage of actually like new GPU cores, new architectures, new functionality, I just see that with some grain of salt always. I would expect that real world results, by which I mean like games, would perform closer to Apple's promised 20% uplift over the M2. But again, not promising anything. It might come below Apple's promises. I have not seen that happen once with Apple Silicon. This is why I'm really careful here. But it's not like I'm afraid to like criticize Apple for something. For example, I've talked about extensively in like my last video how the M3 chip has supposedly a worse Apple neural engine than the A17 Pro, with my theory being that those chips were not designed like simultaneously with the exact same IP blocks, but maybe M3 was actually feature complete a little before A17 Pro, so it mostly got the neural engine from that is basically really in line with A16 and A17, but then A17 Pro had its own neural engine that would actually line up very much with my expectation that we're supposed to get M3 like last year, and Apple just had a little bit extra time to like add some extra functionality to like the A17 Pro, but in the process kind of did not do the same for the M3. However, there are also other discrepancies, like for example, Apple talked about dynamic caching for the M3, but did not talk about it on the A17 Pro. So the architectures might not actually be one-to-one between those processors. They're likely 90% to 95% the same, but there seem to be small discrepancies. So whenever sometimes small like individual results like this don't really show a huge generational uplift, or at least the generational uplift that Apple promised, I always encourage you guys to also consider the actual benchmark, right? You see how architectures are somewhat always changing, even in the same year when we are getting supposedly incredibly similar chips. This benchmark isn't meant for even like to fully take advantage of M2 at this point. I'm sorry. So we can continue actually with the Snapdragon X Elite. This is super interesting because I do know that a lot of my viewers are actually Android users. This is coming in about 6 to 8 months, I would say. They said repeatedly the middle of 2024. It's currently being shown off, or it was shown off a couple of days ago, in both 23 and 80 watt basically like reference designs. Qualcomm does like to give us reference designs. I highly encourage you guys to really take those results and then subtract like 3 to 5% from those results, because on the Snapdragon 8 series, right, their mobile chips, the 8 Gen 2, now Gen 3, it seems like real world results, or at least like benchmarks in the hands of real world people, seem to come below the reference results. For example, I can actually take one specific one here. So we actually have which one was it? Sorry, so many websites to here. The Snapdragon 8 Gen 3 reference design had like in their testing 2330 in single core result when it comes to Geekbench 6. Real actual results with devices like the Xiaomi 14 Pro are showing it to be more around 2200, maybe at best 2250. I don't know if like actively cooled phones will allow for those results, but yeah, just keep that in mind, okay? Now, AnandTech actually has a nice detailed breakdown. I can encourage you guys to read into it. You can actually see that the Max Turbo actually changes significantly, obviously, when it comes to what kind of system it's built into. Now, obviously, that makes sense, as we've also said with like the M2 Pro clocking higher than M2. It's not like Apple is adverse to like giving us different clock speeds based on the kind of performance and power envelope of a device, but this is a pretty big difference of like almost 10% here for the 2-core Max Turbo, over 10% for the all-core Max Turbo, and it's I should note that it's not saying that the Snapdragon X Elite uses 80 watts in this configuration. It's that this is the TDP of the actual device, right? That's how much heat it could handle. But it speaks to the fact that, believe me, if this was a chip that never peaked at like 80 watts in full power usage, they would have chosen a laptop that went to 60 watts so they can advertise it to be really efficient and be more suitable for like thin-in lights. And when it comes to thin-in lights, obviously this is where the compromises for Max Turbo come into. Obviously it's the same chip, so it's using the same memory configuration, but it is using here supposedly 23 watts. Again, for example, M3 is supposedly like somewhere between 15 and 18 watts. This seems to be like pretty much the lowest configuration that Qualcomm is targeting, so I wouldn't be surprised if a lot of configurations came more to like, I would say like 35 watts and really like got you most of the way up to this performance, but without obviously that kind of efficiency, right? It would be closer to this efficiency level than when you fully go up to 4.3 gigahertz on like 2-core Max Turbo, but maybe it would be like 4.15 or something like that. So this is just some extra detail and nuance. I know it's not as spicy because I know people want to see this. This is what we got the first messages in the chat for. This is the Snapdragon X Elite performance. So they've actually done some really good, some really fair result publishing in this case. They have like a 3 test average, which is nice. And then they had like journalist, like, I'm sorry guys when I'm a little distracted, but my cat is literally like non-stop licking my knee, so I really don't know what to say to that. So this is Cinebench 2024. I think we actually have some comparisons points here. Now, Cinebench is not that well optimized for ARM in general, so I cannot tell you how well that scales. So I think it's better to just use Geekbench in this case. Say hello. Will she actually listen this time? Will she not fight me? Oh, she starts to fight me. Okay, good. So this is the Snapdragon X Elite that I would say is the most relevant, and that is the 23 watt variant. And it's, as I said, it's in the 23 watt reference device. It comes to 2777, which would be around 10% less than what we have currently seen from the Geekbench score that I have showed you at like 3080. And then in the Snapdragon X Elite 80 watt design, this is where we get like 2966, so close to 3000. Basically, in real world tests, I would say it's probably indistinguishable from the performance of the M3. However, you now have to consider what the power consumption implications here are, what kind of device you can realistically put it in. The M3, like the M1, M2, M3, those chips exist for like passively cooled MacBook Airs and even iPad Pros. And yes, right now we got an M3 in an actively cooled 14-inch device, similar to how we got M1 and M2 devices in the 13-inch MacBook Pro that were basically had full sustained performance, but single core results between those devices have always been the same, so don't worry about this. Guys, I have to very briefly take care of something. Cheers for once, and I had to make sure I took it out of the freezer because it otherwise would explode. So again, a somewhat big discrepancy here. I wouldn't say it's unrealistic, right? The 80 watt version is 7% faster than the Snapdragon X Elite 23 watt version here. That means it's 6% slower than this. That's actually not bad. When it comes to... Wait, did they not compare multi-core results the same way? Oh, actually, here. I think they did so here, right? Geekbench 2 single core. Really? Bella, stop licking me. No, they did not compare multi-core results the same way. That's unfortunate. Let's just go back to the Anantech stuff. So when I will actually do some of the computations in my head, and I will do a lot of them basically on my iPad simultaneously while we're here, right? So in Cinebench test, between the high performance version and the thin and light, it's basically an 8-point difference here. That's like a 6 to 7% difference. In multi-core results, that's actually a really, really significant difference. This is why I really wanted to see the different Geekbench multi-core results as well. This is well over 20% difference here. This is what we've shown already with the single core results when it comes to Geekbench. And then we have the multi-core results here, which is about a 10% uplift over this here, over the thin and light. Now, when it comes to the Geekbench 6 results on Linux, I would say that I wouldn't take those results too seriously right now. Obviously, they are impressive, right? They're higher than the Windows results here. I would just say when it comes to different tests on different like operating systems, it can sometimes, it really becomes hard to do like a one-to-one comparison. So is it possible that this works faster in Linux actually, like a full like almost 10% uplift here? It might be possible. Oh, there was a multi-core about the graph. Thank you. Oh, that's actually nice. Nice. Thank you. It was so baked into like, you know, like the normal text. Why didn't they make it a little thicker? So this is Geekbench 2 single core. Now multi-core, we can actually work from here. And this is where, well, for one, let's keep with the single core, right? Now we are maxing out, unfortunately, here with the M2 Max. Now there is a point that I want to make, and that has to do with power consumption. Obviously, M2 Pro has the same like it's pretty much the same result here. It's like negligible difference, which is a tad weird given that M2 Max is actually clocked a little higher, but some that will be like variance between testing. It will also come down to Apple does not change multi-core clocks that much once they as they did the single core clock speeds. So here actually from the M2 Pro, which I think is a far more relevant comparison point to the Snapdragon X Elite than the M2, right? I really don't get why people are comparing the M2 or even the M3 with the Snapdragon X Elite. The Snapdragon X Elite has 12 cores, all of them performance cores. This technically puts it likely closer to the peak power consumption of the M3 Max, which has 12 performance cores and 4 efficiency cores. Or at least like, well, the M2 Max had 8 performance cores and 4 efficiency cores, but at least you could make the point, well, it was Apple's decision to make the M2 Max have not too many cores, right? This one will never match like the raw like low power consumption level of an M series chip. Like sure, it might like turn off some of the 4 core like blocks on the die, but it's simply not the same as a chip that is like pretty small by itself, has actual dedicated efficiency cores, has software that is really well designed to shift some tasks between the efficiency cores and the performance cores. So when people compare the Snapdragon X Elite to the M2 or even M3, I really don't understand it. The fact that even this reference 80 watt design exists should show you where it actually will sit in terms of power consumption. Now, in terms of single core result, those are desktop chips, 4900K, 7950X. Actually a nice uplift over the 4900K over the 7950X. And then it's like super close to the 14600K. Again, also a desktop class chip, extremely highly clocked, extreme levels of single core power consumption in comparison to what Snapdragon and Apple will do. But this idea that just because it sits above the M2 Pro here, that it's somehow just as relevant this is just the one thing I really wanted to question here. Now, when it comes to multi-core, and thank you Notebook Chat for doing it this way, and thank you Kulanchizi for pointing this out. Well, at when it comes to the Snapdragon versions, the higher power version performs about 8% better. I would say that's not a bad result, right? I would say it probably means that most laptop vendors will just choose to put it around 23, maybe like 27 watts, right? That's a pretty typical laptop configurations and not do like a crazy 80 watt, spend like double on active cooling, put in larger batteries for sub 10% multi-core uplift. So this is actually pretty interesting. It's actually higher than Intel's currently best mobile processor, the 13900H. Well, it's not the 13900HK, but it's pretty close to that. And when it comes to actually multi-core results, you will see that the M2 Pro and the M2 Max already win versus the lower power version and come damn close to the full power version. I would also really encourage people to look into the power consumption of Apple's Max chips. They sit around like 35 to at worst 50 watts. Like, it depends a little bit on the specific test that you are running. This is way more efficient. Like, I know Qualcomm has shown off like graphs where it's like potentially like 30% more efficient in certain single core scenarios than M2. Given that I know what power this chip uses and in what device they put this chip, I'm really not sure I would fully believe it. I'm sorry, I don't want to sound like an Apple apologist here, but this just wouldn't make that much sense to me, unfortunately. Now, in Cinebench, the 4900K wins, but very little over the 80 watt of this version of the Snapdragon X Elite. The Snapdragon X Elite 23 watt is like 7% slower than the 80 watt version. So as I said before, this version basically probably only exists to beat certain benchmark hurdles, right? And it's compared only to these chips, but I actually do know that the M2 the M2 Pro, the M2 Max gets like pretty much the same result as the 7950X in the latest Cinebench tests. So this would put it very, very close to the lower power consumption version of the Snapdragon X Elite. And given how close everything is together, yeah, that makes sense. And then in multi-core performance, obviously this is where the desktop chips are taking off. And this is where, once again, if we actually look into the benchmarks that we have gotten here, this is why I started with those. This is the M3 Max at 21,000 points, probably like closer to 22,000 than in actual tests. And in this case, that leaves us with CPU multi-core. Wait, what? Why is it? It's Geekbench, by the way. Sorry. Here, this is what I want to say, right? So that is on the level of the 4900K. So I would expect it to perform really similarly in that way in Cinebench. I should say that Intel and AMD are notorious for optimizing their processors for Cinebench because this is a very popular benchmark on Windows. I don't even know, again, as I said, how well the Cinebench 2024 version is specifically ARM optimized. I know it's better than the last version. I know this is at least partially why the M2 Max can get so close in the single core testing to the Ryzen 9 7950X. But in this case, when it comes to multi-core, we're looking at the most interesting point here, right, when it comes to multi-core in general, because obviously this is where we actually have results from Apple, with 11,000 points being the result for the M3, which, by the way, this is a very high M2 multi-core result. At 10,000. Well, it was 11,800, so that would put it as in the realm of the 7940HS. This the M3 already, right, would be here, and then the M3 Max would be here. So I would actually expect like M3 Pro to definitely be around here to here. I would expect the M3 Pro to most likely beat even this performance version of the Snapdragon X Elite. Obviously, I cannot give you any guarantees. And I definitely expect it to beat the Snapdragon X Elite at 23 watts. Obviously, this is all performance cores, 12 of them, while the M3 Pro is 6 performance cores and 6 efficiency cores. But obviously, given how much lower the Snapdragon X Elite has to clock all its cores when all of them are running together, Apple's like super efficient efficiency cores can run at their max frequency, and by consuming very little power, they leave a lot more thermal and power envelope for the performance cores to still run at really good speeds. So it will be interesting how those results actually fare once we actually have M3 Pros and stuff like that. As I said, obviously I cannot speak too much of the multi-core result in Cinebench. Most tests we usually get upfront for Apple's processors are Geekbench. But given the single core here is actually pretty good, I would expect it to scale largely the same as what we are now seeing with, thanks to us also having Geekbench results for the M3 and M3 Max. I would expect largely the same game to play out in Cinebench. Now, when it comes to the GPU, this leads the M2, but is behind the M2 Pro and M2 Max. Now, the interesting chip here will be the M3 Pro, because the M3 Pro, as I said in prior videos, actually has like fewer GPU cores. In its base version, it has 14 GPU cores versus the 16 GPU cores on the base M2 Pro, and on its higher performance version, it has 18 GPU cores versus 19 on the M2 Pro. However, Apple has done some architectural changes. Supposedly the teraflop rating is up. Still, again, I don't do any promises. As I've said with this case, with Vadim's results, I don't want to make any promises for the GPU results, especially not for the Pro chip, for which we have seen no benchmarks yet. And there we also have like the weird discrepancy in like bandwidth, because it has only 150 gigabytes per second versus 200 on the M2 Pro. So I just really wanted to give you that as context. But here is where the Snapdragon X Elite sits. This is actually interesting because this is where we are getting our largest uplifts between the efficient version and the high performance version. We actually get 20% more performance, and it's actually super close to the M2. I've actually ran this exact test on my M1 iPad Pro. I'll just briefly look into what that result exactly was. And that result was 211. So that actually came below the Snapdragon 8 Gen 3 reference design. Now, to me, the question is like, what exactly are they doing here beyond the Snapdragon 8 Gen 3? It seems to be the same architecture here. It's the Adreno 750. That's a little disappointing given that it is coming in the middle of next year. Obviously, I know that we won't even have like a newer Snapdragon chip at that point, but I just wish they had been a little more aggressive, because while the Snapdragon 8 Gen 3 is highly, highly impressive for a smartphone processor, it's a little bit less of a competition when it comes to Apple's M2 Pro and M2 Max chips specifically. And the reason why I really wanted to cover this is because the Snapdragon X Elite, some people are trying to compare it with Apple's M3. I've already outlined why that is ridiculous. I've already said that its biggest competitor is probably like a mix between the Pro and the Max chips, and now that the M3 Pro and the M3 Max exist, definitely the M3 versions and not the M2 versions. It will come out 8 months after Apple's M3 chips, but it sits behind the M2 Pro and it's a lot behind the M2 Max. Now, This is obviously in terms of GPU performance over the high performance version, the M2 Pro already beats it by 38%, so expect like an M3 Pro at its max config probably beating it out by 60% or something like that. But when we actually look at a more relevant comparison and we look into the Snapdragon X Elite, the 23 watt version, well, now you can the M2 Pro already beats it out by almost 69%, which would be nice, but it only beats it by 68%. So my question is, will the M3 Pro potentially offer double the performance of the Snapdragon X Elite at similar power consumption envelopes? Because that would be a huge downgrade over the experience on smartphones, where the Snapdragon 8 Gen 3 handily, at least in in those specific tests, as I've said before, GFX Bench is not really a great test to test highly modern architectures with great new functionality, but the Snapdragon 8 Gen 3 handily beats the A17 Pro in this test. So my question is like, why could you not have done something that at least matches the actual chip that you want to compete with? Because believe me, the Apple M2 is fine here, right? The M3, even with a small uplift, right, will come extremely close to this result, right? And that is the low power version that just does not compete in the same league as those chips are supposed to do. There is no 60 watt version of the M2 or anything to even come close to this. What Apple has instead is the M2 Pro, a better mix between like performance, efficiency cores, obviously much more GPU bandwidth as well. You should also consider here the M2 is running at 100 gigabytes per second with its bandwidth. These have 135. They use LPDDR5X. This just uses LPDDR5. Unfortunately, the M3 still only uses LPDDR5 rather than LPDDR5X, or what I would have preferred, LPDDR5T, which would have been like 50% faster than LPDDR5, which this also, by the way, adds credence to my theory that M3 was probably should have come out last year, and the only reason why it's coming out this year is because 3 nanometer was delayed. This is, I believe, why we also had like rumors about the A16 potentially getting a large GPU architecture redesign, but that not being possible on 4 nanometer. And yeah, guess what? That probably means that this is exactly what we got in the A17 Pro. We got the mesh shading support, we got the ray tracing support on the Mac processors. We're getting dynamic caching and stuff like that. So yeah, we definitely got our new architecture from Apple this year. So yeah, the GPU uplift definitely not being as impressive as the CPU comparisons to the in comparison to Apple's processors. This is actually problematic due to another problem for the Windows laptops, and that is that supposedly we were getting Strix and Strix Halo APUs next year from AMD. It seems like we are only getting like the lower GPU core version, and it's probably coming in the second half of the year, like later in the second half of the year versus like late summer, which is what most expected. And it seems like the high core GPU version, which would have like 40 cores of RDNA 3.5, is supposedly delayed all the way until 2025, which is also when we are getting NVIDIA's RTX 5000 series, which will be Blackwell, and by that that point, we're also getting close to Apple's M4 chips. Again, I cannot guarantee when exactly we're getting them. How we might get M4 in exactly a year, which would be hella impressive. And I actually hope that if Qualcomm keeps up their game and like in exactly a year is about to launch a processor that might have like double the GPU cores that you find in the Snapdragon X Elite, maybe they would have like a Snapdragon X Elite 2 and the Snapdragon X Elite 2 Pro, or 2 Elite, 2 Furious, or something like that, then Apple would, knowing that this might happen, Apple would have to start preparing like this year already to think like, oh, should we wait until with M4 until like early 2025, or should we push TSMC's M3E? Should we push our own architectural teams? Obviously, I know chips are started like 3 years in advance, so there might not be too much levers that Apple can pull right now, but Apple knows at this point that they need to step up their GPU game. As I said before, the Snapdragon 8 Gen 3 beating the A17 Pro in artificial benchmarks at the very least, but if there is a chance that this could like get close to M2 Max right next year, then Apple definitely would have to consider something in response, given that M3 Max, while it will definitely have a better GPU than the M2 Max, it actually won't have too much more like raw rasterization performance. It will have like your mesh shading support, your hardware accelerated ray tracing, but it might only be like at around 1100 FPS in this specific test. So if they really double this, that would make it a more meaningful competition for what we are currently getting with the M3 chips. Now, I do wonder if we might get a bigger version of the Snapdragon X Elite based on the same architecture. I kind of don't believe so. I think we will get a sequel to this chip based on N3E, and this is the point where we might have a version with more graphics execution units. This is, by the way, I've said that on Twitter. I think the balance on the Snapdragon X Elite is wrong. I think the balance exists so that it can actually like compete with Apple in single core results and a little bit in multi-core. That depends on what chip you want to compare it against. Obviously, if you take last generation, then yeah, it is competitive in multi-core CPU results, but not with the new versions actually. But in single core, yeah, that might make it even somewhat competitive to M3. Put it definitely below it. Again, look at this result, right? 300 points below the M3. But when it comes to the GPU, my question is like, really? You have 12 performance cores here, right? This is why you can get all the way up to 15,000 points in Geekbench, 17,000 if you believe the Linux testing. My question about this is like, really, you didn't feel it's like necessary to maybe give us like 50% more graphics execution units than it's currently here? Also, look at this. The Snapdragon X Elite GPU is fully compliant with DirectX, but only to DirectX 12 feature level 11, which means that ray tracing, verbal ray shading, and mesh shaders are currently not supported. So I don't, this by the way does not impugn this test. The Aztec Runes normal tier test is like super old and does not rely on any of those modern technologies. But I just find it funny that that we have like them showing off this processor this early, not even fully being like compliant with the latest DirectX version. Right, because the reason why I want to highlight this is once again to hammer home the point that this is a chip that is only coming out in like 8 months. So obviously by that point I expect them every test to be ready, every API to be feature complete, but it's just funny to me how many people live that out completely in their coverage, that they're like, oh, it's already beating the M3, by the way, that will be out this week, and then like over the course of this month will be out even on like as far as the M3 Max. But this one that somehow only beats the M2 in terms of GPU performance, a chip that is over 2 years old, by the way, and is built on a worse node. This is N5P. As far as I know, this is N4P by 6%. The fact that they didn't think of hitting at least this kind of level of performance at this efficiency, which for that you would need like more GPU cores, I that just is inexplicable to me. Like, this is 22% faster than the Snapdragon 8 Gen 3 reference design with the same GPU architecture. So yeah, that is weird to me. And the company did indicate that they're pushing for native ARM games, by the way. Control, interesting. It's a very high-end game. We just got Alan Wake 2 from the developers of Control. Baldur's Gate 3 is already a native ARM app on Apple Silicon. I don't know much about Farming Simulator. Obviously, Minecraft has had like their mobile versions for quite a while, so I assume this would be a full port of like their full PC game. So that's nice. No mention though of like anything truly new. Like, Control is older at this point. I mean, like, Apple does that too, right? That's why we got like Resident Evil Village just for the A17 Pro. But Apple's push for older AAA games largely comes down to those games also working as slow as on the iPhone. I don't know if Qualcomm is pushing to have those native ARM games also ported to Android so they can work on the Snapdragon 8 Gen 3. Right, because obviously if they're built now for DirectX 12 for Windows on ARM, that doesn't mean that the porting process to Android will automatically be super easy just because it's ARM. There will also be DaVinci Resolve 18 as a running here for non-ARM, but doing very fast AI computation, because while obviously the x86 chips that they compared it against do not have AI accelerators, though does not, like, I believe the which test did they do? Okay, I just don't think they because I know the latest AMD chips have like AI accelerators, but they're supposedly not that great, so I wouldn't put it past them to win against them. So obviously all of this is a result for like from their Orion CPU, with them buying Nuvia, with Nuvia being partially built by people who previously worked on Apple Silicon. There's a long-standing lawsuit here going on about Nuvia potentially using Apple's intellectual property. To be honest, I'm not too interested in that. We'll see where the dice falls basically on this point with the lawsuit. You can see that it's not that impressive, right? Over M2, again, an over 2-year-old chip. Oh, by the way, did I say over 2 years old? I'm sorry. Over a year-old chip, right? Wait, when did the I think I'm going crazy. The M2 launched in summer 2022, right? M2 chip wiki. Yeah, it's summer 2022. I'm sorry, I think I misspoke before, and then I basically repeated that mistake afterwards. The M2 is launched in summer 2022, so that's almost 1.5 years away. It's not 2.5 years away. The reason why I sometimes think of M2 as like a 2021 processor, because that is when the A15 came out, and this is actually when we were supposed to get the Apple M2 most likely, but the problem was like that we were like with giant pandemic shortages, and Apple still was figuring out like the entire M series of chips. So this is when M1 Pro and M1 Max came out, and this naturally pushed M2 a little further away. So yeah, I apologize for me speaking earlier. I think I'm kind of still distracted because my cat was like licking me half of the stream. So even though she's sleeping now, I'm still like anxiously looking behind my back if she would start doing that again. So what does the Nantec have? I think they probably don't have that much else. We have PC Mark applications here. This is just comparing them against each other. Those are the GFX bench results that we've also seen outlined in this test. 3D Mark Wildlife Extreme, 45 to 44. I don't actually know if I have any 3D Mark Wildlife Extreme M2. Okay, let's just take the M2 Pro for example. As I said, I don't consider the M2 3D Mild Wildlife Unlimited. Here, 3D Mild Wildlife Extreme, 65 FPS here versus 39 and 45 FPS here, so definitely superior on the M2 Pro. When we look at the M2 Max, you can find it being 116 frames per second. So again, over doubling the results of the Snapdragon X Elite here. Way over doubling, by the way. And then over the regular M2, does it have that? It's actually interesting, benchmarks.ul. I'll just like, can I look for a specific processor here? Because this is actually a pretty nice website in that was compared GPUs. Okay, laptop, desktop, model name, M2. Does that help? No. I can only look at graphics cards, unfortunately, here. So it's a weird limitation. Can I not look for an actual laptop? If that's a 3D Mark's graphics score. Yeah, this is stupid on my part. I mean, I could make like a guesstimate on like regular M2 performance, but like, oh, here it is. Here's like M2 in 3D Mark Wildlife Extreme. This is 6,773 points. Obviously, the result we got there was in terms of FPS, but when we actually look at this here, this gave us over 10,956 points. So M2 would actually most likely be around the results that we're seeing here from the Snapdragon X Elite. Might actually be a little lower, similar to what we've seen in other tests. So again, that at least makes sense. It would scale similar to what we're seeing here with the Aztec Ruins test from GFX Bench. Just wanted to make sure I wasn't saying anything wrong, guys. This is why I really wanted to like fact check myself here. So yeah, this is basically what we currently have. A little bit of everything, right? Some leaks with some early M3 Max results. Them lining up pretty well with what Apple promised. Still not quite understanding what exactly in terms of GPU performance we'll be getting, especially as I said before on the M3 Pro, where there are some core and bandwidth discrepancies in comparison to the last generation. Whatever you get, it's definitely all going to be better than the M1 variants that are similar to that, but I don't want to promise too much. Then on the M3 Max, we get like super impressive multi-core performance. I still cannot fully promise you what the exact like single core result of the Max chips will be. If they're actually clocked higher than the Pro and the base M3, they might not be, similar how the M1 generation was entirely one clock speed, or they might be ever so slightly higher clocked as the M2 Max was higher clocked than like the base M2. And then we have like plenty of comparison points now with the Snapdragon X Elite. Thank you actually Qualcomm for going so much into detail. The only outlier here being the Linux results that are noticeably higher than the Windows results. So I took them for now as non-relevant. That's not to downplay those chips. It's basically to say this is a chip that is specifically being built for Windows. They're currently testing it for Windows. Maybe some kind of specific optimizations with drivers and stuff like that will make them offer that kind of performance. But for now, I take these tests more as representative, especially given that this chip is still like 8 months off, 6 to 8 months off. So I do not want to overpromise based on those results. And in terms of GPU, this is some of the results here. As I said before, they're higher than the M2 chip, but the M2, the base M series of chips, have never been the main competition for this processor. Given its 23 and 80 watt variants, it's far more of a competitor for the Pro and Max variants of Apple's processors, and this is where unfortunately it is like far behind even the last generation of Pro and Max chips, and definitely will be like a lot behind the M3 variants. So I just really wanted to cover all this. It's all good, by the way. Nothing that I see about this chip is bad. Obviously, we need more competition both for Apple, but I would say specifically versus Intel and AMD. I also say we specifically need for Windows on ARM to actually finally work, for more apps and games to natively work well with Windows on ARM. And if this chip helps us along with that, I would say it would need a little bit more GPU performance to realistically push us into needing a more adoption of Windows on ARM. About the 7940HS like not delivering great results in this test, but there's a ton of alternatives to the 7940HS. This just happens to be a relatively decent like APU version. When it comes to actually like dedicated graphics cards and Windows, those will be way closer to this than anything down there. So I don't know if what Qualcomm is doing here will be enough. I do have some questions, like the complete absence of any efficiency cores. Like the Snapdragon 8 Gen 3 has like one of the of its like premium cores, right? The X4. Those one have like their new Orion CPU cores and 12 of them. So it's actually pretty crazy to predict for me like what exactly the power consumption, the battery life, or the overall efficiency of the chip might look like in the end, how well Windows on ARM will actually be optimized for it by then, and then of course what the devices with this chip will actually cost, given that it is a pretty decently large chip. It has like 12 CPU cores on 4 nanometer. It does not have the largest GPU, but still decent one. So yeah, it's interesting. I do not want to promise too much. I do believe that Apple's M3 generation is more impressive, simply also almost by default, as it is coming out now and it's built on 3 nanometer. There might be specific points where it loses. For example, I would expect the Snapdragon X Elite to win in artificial intelligence tests that run only on their version of the neural engine, and that probably comes down to them actually utilizing a very new neural engine, while the M3 chips don't have the same neural engine, as I said before, as on the A17 Pro. They actually have one that is pretty much in line with what is on the M2 generation, just clocked higher. So it's not like I want to take everything away from the Snapdragon X Elite, but I really wanted to give some nuance because I've seen some interesting discussions. Now, don't get me wrong, if if you want to compare pricing, it's very likely that the Snapdragon X Elite will be easily found in like $1,600 devices, which is currently where the M3 sits in like the MacBook Pro. But don't forget, there's also like the iMac that is actually cheaper. There will likely be an M3 MacBook Air at some point. So maybe even before the Snapdragon X Elite officially comes out, maybe we'll have like a new MacBook Airs at that point. And then of course you do have to consider the fact that like if you actually want comparable battery life, well, that is like impacted by a more performant SoC, well, then you would have to look at Apple's Pro and Max chips that are obviously in like actively cooled larger machines. I know the M3 sits in like the 14-inch MacBook Pro, but it only has like one fan, for example. The cooling assembly is far less big than what we have on the Pro and Max variants, which are also which also make those designs heavier by default. So I just really wanted to give all that nuance. I'm kind of confusing myself with all those numbers. That's why I wanted to make this live. Thank you to YouTube Cool and Cheesy for correcting me when I was slightly going off course. Thank you for giving me a tip for like finding those like buttons here that I for some reason oversaw. So this stream would not have worked as well without you. Thank you so much for that. I would have had to do a lot more computations in my head, which again I'm good at, but I don't really want to do. And for anybody watching right now, we've added, as I said before, like 80 subscribers since yesterday. I do want to encourage anybody who's watching this and who hasn't yet subscribed to subscribe, like, share. And if you want to support this channel directly, you can find the link to my Patreon account in the description. If you want to support me live during the stream with a super chat or a super sticker, that's super welcome. Or if you find the video afterwards and want to send me like a super thanks in the chat, that's of course also very much appreciated. And with that, I'm saying thank you and goodbye. This is Mark Tech tuning out.